Another thing that becomes very important when we are talking about vectors is equivalent vectors. What are equivalent vectors? When we have two vectors, A and B, they will be called equivalent if and if only they have the same magnitude and the same direction, which basically means is if AX, which is the X component of A, equals the X component of B, and AY, which is the Y component of A, and B equals BY, which is the Y component of B. Two vectors are equal to each other if and if only their corresponding components are equal. So now let's look at this example. There is a vector A that has AX and AY, and then there is another vector B that has BX and BY. Now, are these both equivalent vectors? What do we know about equivalent vectors? Basically, what we know about equivalent vectors is the fact that AX and BX will be equal to each other if and if only their components are equal. So let's look at them. Is AX equals to BX? Yes. Is AY equals to BY? Yes. Is both the directions the same? Yes. That means A is equivalent to B even though they do not both start at the origin 0. Adding vectors. We can add vectors mathematically or we can add vectors graphically. When we add vectors graphically, we do it by something called the head-to-tail rule. And this is what the head-to-tail rule is. So let's suppose you have two vectors, A and B, that are given as that over here. Now we need to be able to add the two vectors. Now how do we do this? Both of them have components AX and AY, BX and BY. In order to add these two vectors, what we need to do is we need to draw AX and AY again. Then we need to move the vector B to the head of vector A along with its components. Then we need to draw a line from the tail of our first vector to the head of our last vector, which will give us the resulting vector with components Sx and Sy. This is called head-to-tail rule. We can add any number of vectors using this way. So let's say if you had 3 vectors, how would they be added? The same way. You will put the head of the second vector, you will put the head of the first vector with the tail of the second vector, then you would take your third vector and you will put it towards the head of the first vector, and so on and so forth. Vice versa, your resultant vector S can be calculated by just simply adding the components of vectors A and B. This is how we do it mathematically. So Sx and Sy basically are just AX and AY, BX and BY added together, like this. So the net result is the S is actually a sum of the two vectors AX and BX and and two components AX and BX and AY and BY. Okay. Multiplying a vector by a scalar. Well, if you need to multiply a vector by a scalar, what you need to do is define what a scalar is. Let's say we want to multiply it with 2. That means it becomes twice what it was. Note the direction remains the same, it's just that the magnitude of the vector becomes twice. Now if I was to multiply a vector by a scalar in such a way that the scalar was actually negative value, what will happen? Mathematically you will do the exact same thing, except your answer now will have components minus and minus. Now go back and recall, what did we learn about coordinates? So both AX and AY are negative. This means now, what quadrant should it be? We start from here. 1, 2, 3. This is minus, this is minus. So we should have an answer in the third quadrant, which is exactly what we get. Now let's look at an example. Example 1. An airplane travels 209 kilometers on a straight course, making an angle of 22.5 degrees east of north. How far north and how far east does a plane travel from its starting point? So now, here's a very interesting problem. It's saying that an airplane travels 209 kilometers on a straight course, making an angle of 22.5 degrees east of north. So first of all, we need to be able to define what our coordinate systems are. So, in general, people always define north and east. Okay? Which in turn means that my south is here and my west is here. Okay? Now it's saying that the airplane travels 209 kilometers at an angle of 22.5 east of north. So east of north means that we will come towards the east starting from the north. So my 22.5 degrees is this angle. Okay? And the length of my vector is 209 kilometers. 209 kilometers. Okay? So that means my vector R is 209 kilometers. And my angle theta is 22.5 degrees east of north. Okay? And now he's asking how far north and how far east does the plane travel? So I'm basically required to find how far east and how far north does my plane travel. Okay? Now see a pattern here? This is my original vector. This is now going to be my AX. And this is now going to be my AY. And now I need to be able to find what this angle is in order to define it. So if you note, this is now going to be your 90-degree angle, right? So if this is 90 degrees, what should this angle be? Okay? Yes? So let's call this angle phi. Phi should be equals to 90 minus 22.5 degrees. Right? Which, if you have a calculator handy, it comes out to be 67.5 degrees. Okay? Now, how do I find AX and AY? Well, it's not that as hard as what you think. So AX, we defined it to be equals to the vector A times cosine of phi. That means I can put in 209 cosine of 67.5 degrees. And AY is A sine of phi, which is 209 sine of 67.5 degrees. Go ahead, quickly plug the values in and come up with an answer. So go ahead, plug in the values and come up with an answer. And I get, when I do the calculation, for this one I get 79.9 kilometers, which I can approximate to be 80 kilometers. And for this one, for the AY, I get 193 approximately kilometers. So this is how far east, and this is how far north the plane has moved. Now the next question asks, an automobile travels due east on a level road for 32 kilometers, then turns due north at an intersection and travels 47 kilometers before stopping. Find a vector that indicates the resulting location of the car. Now this is opposite to what we've already done. First we were given the resultant and we were asked to find the components. In this case we are given the components and we are asked to find the vectors. Let's look at this problem. What it's saying is, here's my car, it first goes due east for 32 kilometers, and then it goes north and travels 47 kilometers. And what it's asking us is find a vector that indicates the resulting location of the car. This is going to be my resulting vector. So now, since they're asking for a vector, we know that a vector should have magnitude and it should have direction. Okay? In order to calculate the magnitude, what we need to do is we need to use the resultant S, let's say S, will be equals to ax squared plus ay squared square root, right? Where this is ax and this is ay. Okay? This means I can plug in 32 here squared plus 47 squared here, square root. Get your calculators out, do a little bit of a math, and what we end up with is about 57 kilometers. Okay? Now what about direction? Direction is going to be this one. Now let's call it theta. So we know in order to calculate the direction, we have to do tangent of theta equals ay over ax, right? So ay is 47 divided by ax, which is 32, and tangent of theta. So this means theta is actually equals to tangent inverse 47 over 32. So if you have your calculators, bring out your calculators real quick and do the math. And my answer comes out to be about 56 degrees. Now please confirm, while you're doing all of these problems, I don't want you to just take my word for it, but actually come up with your own answers, because part of the problem is that people kind of forget to do their own calculations, and then they run into trouble when they're trying to do these problems on their own. So please have your calculators ready, have them in your hand, plug them in, and come up with answers. Okay?